In classical mechanics, if we know the position function of a particle, then we can tell a great deal about that particle. For example, if we took the derivative in respect to time, then we know the velocity at any given time for that particle. And if we know the mass of the particle, we also know the momentum of the particle. And we also know the kinetic energy of the particle as well. Needless to say, the position function for classical mechanics is very important. So how exactly do we get it? Through Newton's second law. Or in terms of differentials, we can go even further and relate the potential energy of the system to Newton's second law by knowing that the loss of some change in potential energy over some distance dx is equal to the force that was applied over that distance. These two forces are the same, so we can equate Newton's second law to that loss of potential energy. So in classical mechanics, the position function and this equation are very important for determining a lot of different characteristics of a particle. In the quantum world, we still have kind of the same analogous equations and functions. Analogous to the position function is the wave function. And it's some function that we denote psi, and it's some function in both space and time. In the quantum world, the Newton's second law equivalent is called the Schrodinger equation. It's complex. It involves Planck's constant. It involves the time derivative of psi. It involves some more constants and also the mass of the particle. It involves some second derivatives of the wave function in respect to space, and the potential energy is thrown in there as well. And just to note, this Planck's constant is actually his original constant divided by 2 pi. So the wave function is analogous to the position function in classical mechanics, and the Schrodinger equation is analogous to the Newton's second law in classical mechanics. So what exactly is the wave function and what exactly is the Schrodinger equation? That's something we're going to cover in later chapters, but just know that when we start off with quantum mechanics, that there's some wave function that's going to be analogous to the position function. Again, that there's some equation called the Schrodinger equation that we use to get the wave function, and that's analogous to Newton's second law.